Hello, everyone. Welcome. I'm Matt. This is Ryan.
Cheers.
We are developers in a group called DX, which stands for Developer Experience. So we're very interested about the overall developer experience when folks like yourselves adopt our platform. And we are here. Why we're here?
Well, in the last year, about a year ago, Satya announced Conversations as a platform and the bot framework. And where we expected some interest from our partners and our customers, we couldn't possibly have imagined the magnitude of the response we would get. Thousands of developers were pulling our code down from GitHub, and we actually worked with about 100 companies this year to actually build out these conversational interfaces, which we call bots.
Right.
Now, in the process of building these things, we found several patterns and practices that we want to give back to the community and actually share so that when people are building bots in the future, they have some reference points.
Right, and it's important to, I always reinforce the message that we are not bot experts, because I don't believe there are any bot experts out there. It's such a new thing. We're all learning. Like when you look at web development, mobile development, the design patterns are really well defined. Like you know how to do breadcrumbs and MVC, MVVM. These things are well known. In the bot space, we're kind of like figuring these things out, right? We are learning and building. So what we're going to show here is what we've learned from several months of building several bots for different companies. Come back in a year and they have a whole bunch of new lessons that we're learning. The technology is evolving as well, right? But I think those are valid things that we would like to share with you, right?
Great.
So you want to talk about the next one?
Yeah, let's go ahead and get started.
Right.
Yeah, so throughout the talk, we're going to address a few different things. For one, we're going to talk about some of the new docs we've pushed out. We're going to very generally give an overview of the bot framework and what it looks like to give context to those who haven't used bots, which is probably a lot of you. And then we're actually just going to dive straight into some of the best patterns and practices we've found when building these with our customers.
Right, and almost every slide we're going to use, or every topic we will mention, we will be referencing these docs. So a lot of the feedback you guys gave us was, you guys need to improve your documentation. Good news, we just did it. So if you go to this page, you see a lot more details about how we usually solve problems. Typical things you guys bring to us, like how do I build a bot that answers general questions and answers from a database? Right? Typical thing. Ryan wrote a whole article about it. That's his thing, knowledge-based scenarios. So we'll be referencing this all the time throughout the slides. When you download it later, please click on those links and go check this in the documentation. We're super happy with where things are getting at this point.
Yeah.
Right? Should I talk about that one?
Anatomy here? Yeah, absolutely.
Yeah, sure, let me do that. So before we start, some of you guys have been building bots, even in our platform, quite a lot. Some of you could probably just come here and do this presentation instead of us. There are other guys who never built a bot before, don't know anything about our platform. So just to make sure we're all on the same page, when you talk about bots, we're basically talking about building little REST APIs, right? So basically, we're focusing on this thing that we publish. You may host this on Azure. If you're hosting on Azure, that's great. Love you guys. If you decide to host it somewhere else, that's fine as well. All you need is a REST API hosted somewhere. And then what you do is you go to the bot framework and say, here's my REST API. Here's where my bot brain sits, right? And then from that point onwards, the bot framework will be doing this messenger back and forth between different channels like Facebook, Slack, Skype, custom channels, whatever custom apps you're having. Like we'll show later today a little robot where we're using bot framework in the same model. When you use custom apps, we use this thing called direct line. So you actually, it's just a REST API. You can build your own client. And whatever how smart your bot is really depends on what you do with it, what APIs you're using, how much code you have in there. So, for example, you could be using our cognitive services. You saw a little bit of that today in the keynote, where we have things like language understanding, translation, vision, search, speech. All these things you can use in your bot. You're not forced to use Microsoft APIs. That's another common mistake. I've seen people saying, I'm not going to use Microsoft Bot Framework because if I do, you guys are going to force me to use our cognitive services. No, you can use whatever you want. If it's a REST API, you can call it, right? It's just C#, Node. So basically, we offer a couple of different SDKs, C# and Node. They're open source. You can just take them. And call anything you want, custom APIs, other APIs, storage, databases, anything, CRM systems, whatever. So this is basically how the bot framework, the overall architecture looks like. So most of what we'll be talking about sits here in this little REST API. Yeah, there you go, perfect. Yeah, that's on you.
Yeah, so as Matt really just emphasized here, you're using a lot of the same services when you're building a bot as you would when building an application, a website, or a web application. The only real difference here is that a bot is just a new user interface. You're now using conversation to interact instead of necessarily a GUI or a command line. So to jump into a very quick history of of user interfaces, just to give some context for conversation, we of course started off with the command line. Now command lines are incredibly powerful. You use very specific language to tell a computer exactly what you want it to do. I still use a command line every day. Unfortunately, command lines are inherently unintuitive. You have to learn the exact language of the machine in order to get it to do what you want it to do. So we moved on to graphical user interfaces. Instead of users having to figure out the language of the machine, we show them what they can do with windows, icons, menus, and pointers. This was obviously a huge stride, but it still can be incredibly difficult to learn how to use an app. Menus might have different submenus, and learning how and what an app can do can still be a massive undertaking. So as my colleague Bill likes to say, the overarching theme in our user interfaces until now has been that it's the user's job to figure out the computer. We've had to use some cognitive load to translate what we want to do into computer speak. We're finding now that with conversational interfaces, it can instead be the computer's job to figure out the user. So how do we accomplish this? And why are we able to accomplish this now when we haven't been able to in the past? The short answer is natural language processing. Thanks to the advent of machine learning, the increased rate of growth given Moore's law, and the massive availability of computing provided by the cloud, we can very easily build models that understand examples of human language. So we have a cognitive service called LUIS. You train it with what we call utterances, which are examples of what a human might say to your bot. And we map it into different buckets that we call intents. So I might say, what is the Microsoft stock value today? And the intent that I'm mapping that utterance to is check stock value. So I can now turn a human input into something that the bot's going to go ahead and do. It's going to go ahead and call an API to find out the stock value. When we train these models, we also train them with the entities that we want to pick out of those utterances. An entity is really just a noun. It's a thing that we want to pull out. So in that example I just gave, check Microsoft stock value, I would pull out the value Microsoft so that I can then pass that into whatever API I'm using behind the scenes. Now, natural language processing isn't a new field, but given the progress we've made with the machine learning algorithms we use and the ability for us to democratize these APIs and let anybody extend models as, however they see fit with their own data, we can now use them as any developer as opposed to having to be a data scientist in order to create a natural language model.
All right, and another interesting concept that once you get it, things get so much easier in the bot development space, is the concept of dialogues. If you're a traditional app developer, website developer, you break your UI into little units of UI and usually call them screens, windows, forms, whatever the platform you're using, right? But you basically break those things into small units. And that's how you, developer, don't go crazy with too much stuff in one single UI, right? And you don't drive your user crazy as well with too much stuff in a single UI. Move to the bot space, that doesn't change that much. You still need you still need to create some units that you can break down your logic. You can have multiple developers building different parts of your bot and so on. And we call those things dialogues. So basically, a dialogue is an interface between the bot and the user, right? And those may be just text. In a simple bot, maybe just text going back and forth. It may be a richer thing. It may have richer cards with buttons, with images. Like, it's not just pure text, but it's a UI. And like happens with apps and websites, a UI can call another and another. So a dialogue can invoke another and another, right, and back. So they can redirect each other. When dialogues redirect each other, they stack up like a stack. Like, so you think about traditional apps where you have modal windows, right? Same concept here, and with the same challenges. Too much modality is a problem. It's kind of like we've seen this across most platforms. Like we see even other developers outside Microsoft suggesting that too much modality in bots, it's kind of hard to manage. So you have to be really careful with how many steps into multiple dialogues you get there. And one of the reasons is that humans don't communicate in stacks. So I'll give you a very simple example, right? I go home and my wife decides to tell me a story about how her day was, right? So she tells me that story, I have that story in my stack in my mind, right? When she's about to finish the story, she changes to another story. I'm like, okay, I'm stacking up now this new story on top of the old story, right? And I create this expectation that at some point she will go back to the original story and finish it. Sometimes she never does it because nobody told her that's how you're supposed to communicate. She's having a good time and sharing that with me, right? Same thing can happen with a bot. So you're doing an order, right? And the bot says, do you confirm, yes or no? Maybe the user will reply, well, what was the price again? And you're not expecting for that answer, right? Now, what do you do now? And that breaks the whole model here. And so you can have it, but you have to have mechanisms to trigger when the user wants to change the subject. And Ryan will talk about this later today. How do you detect that? What do you do about it? But basically, that's how dialogues work. So now we'll talk about a series of, we're taking the liberty to call these things patterns because we've seen them so many times that it kind of looks like a pattern now. We kind of know the ones that tend to work well and the ones that rarely work well. So we'll talk a little bit about patterns and anti-patterns in that example. But just when you hear us saying this term, just assume we're just talking about examples we've seen a lot, right? We're not trying to dictate this is the universal truth of how to build bots. It's just what we've learned. And I'll start with the most common, I call it the anti-pattern, the most common mistake that a beginner developer tends to fall into. When you're building a bot for the first time, the first thing you probably do is start with, how can I help you, user? That makes a lot of sense, right? That's logical. Your bot is trying to be helpful. How can I help you, user? There are a couple of problems with that. One is, user, I don't know, because you didn't tell me what you can do. How can I know? How can you help me? And that's why if your bot does 100 different things, very, very likely your user will guess 3 of them at best. How can I know all the other 50-something, 80-something things your bot can do? That's one problem, discoverability. The second problem is how to model that with natural language, because it's such an open-ended question that no matter how good is your natural language model, I promise you, you're going to miss a lot of scenarios. Users will say things that you never expect them to say. Right? So for example, a healthcare bot says, how you're feeling, user? And the user say, I'm a little bit sad because, it's not been sunny recently, so I think maybe the lack of sunlight. How are you going to deal with all that blabbing, right, and make something meaningful out of it? So modeling these things in natural language alone is really hard, and that's usually how we find out somebody's falling into that trap. Like usually somebody reaches out to us and say, oh, my natural language model is blowing up. The natural language API is saying, it can't handle more utterances. Like I reach my limit. Now I have to create multiple natural language models to do so. Okay, hang on, what are you trying to do? I'm just asking the user, how can I help them? That shouldn't be that hard. That cannot be that hard. Turns out we developers have been solving these problems for decades with a very simple solution called menus. You click on them and they work, right? They are great solutions. There are 2 things there. One is they are discoverable. So I look at it, I know what your bot can do. That's one great benefit. The second benefit is I don't have to type so much. And people assume that bots are all about typing. Actually, the best bots are the ones where you type less, not more, because typing a lot kind of sucks. It's not a good experience.
To add a point there, I mean, the goal of an enterprise bot is not to solve the Turing test. You're not trying to build an agent that you can just chit-chat with all day and seem like a human. Really, you're trying to build a new user interface to access the same services you are already providing. So you want to minimize the number of steps your user has to take. as opposed to having a big, lengthy conversation that, that operates much like a human would.
Right, and at the end of it, you can always, like we're doing here, we're suggesting the user, hey, by the way, you click 3 buttons here, you could have just say this, and I would know what you want. In the majority of cases we see, even doing this, the users click the buttons every single time. Not always. I just heard an example. It's exactly the opposite. It's great that not all users are the same, but that's usually what we see. So the other common anti-pattern we see a lot is the choice of the wrong canvas or the wrong kind of input. So people, for example, assume that because they're choosing speech, everything magically becomes more natural. Not really at all. And so the first example is a real-world example, somebody building a password reset bot. So I forgot my password, I call this thing and say I forgot my password. How does a password reset bot work? Like any app, first thing is, hey, I need to validate your social security number or something that proves you are whoever you are. Okay, I did it, now I reset your password, now I give you a new password or a hyperlink, right? That's usually how it goes. How am I going to do that via voice? How am I going to give you a new password or a hyperlink via voice? It's not the optimal. I don't want to read out loud my social security number in front of you guys so you guys can hear so voice there may not be the ideal thing. Maybe I'm doing a chart, like a very rich chart with drill down, with a lot of information. It's hard to replace that with just voice. You don't have that much bandwidth there to pass all this information. Another example is a chess bot. We've seen that as well. Somebody building a chess bot via text. Have you tried to play chess without a board? Like some of you may be able to do it. I cannot play. I need to visualize it. So it's very hard to replace that drag and drop and visualization, right, with just text. Playing Halo. Try to play Halo with typing, right? No, move left, the other left, no, just like you don't get the latency, the short latency you need for this sort of game. You need a controller. So before you make an assumption that voice is the right choice or text is the right choice or whatever is the right, put yourself in the shoes of the user, right? And imagine, does it make sense? And if you start getting that feeling that that doesn't make a lot of sense, that probably doesn't make a lot of sense. That's probably a red flag right there that something is wrong. So user experience comes first, right? Again, to what Ryan said before, your business requirement probably isn't to beat the Turing test, is to solve whatever the user's problem is in the best possible way, the quickest possible way, because that's what drives adoption, right? It's the easiest path is where users tend to go. So we see that a lot. We see people choosing a channel or an input format that is not optimal for whatever they're trying to do. Knowledge bots?
Absolutely. So the most common pattern, the most common type of bot we see our users building are knowledge bots. At its core, a knowledge bot is basically a bot that can reason over some corpus of data and get some information back to a user. So tons of different bots will call some database, call some API in order to reason over some data and get some information. This year alone, I've built several event bots, help desk bots, contact bots that inform the way they have the conversation on that underlying data store. So there are many patterns we've found in that process. Examples of questions you might ask a knowledge bot are, when is Matt Veloso talking? In this case, we need to parse out the word Matt Veloso, know that it's a name, and know that we need to search some underlying database with it to find out, what are we looking for here. What genre is Beyonce? Again, we need to hit some database behind the scenes that has some information about an artist at a music festival. Or who is the program manager that I spoke with at last week's stand-up? Again, we're hitting a database to get back some information to a user. So it's pretty straightforward. One of the tools we've found is most useful in building these knowledge-based bots is not necessarily natural language processing, it's search. So we've been working on search algorithms for decades now, and we've built some very powerful search experiences, and we can absolutely use these in our bots for a few different things. For one, we can use search for fuzzy searching. We can't expect our users to type things exactly as they appear in a database, so we can take their input and pass it, run it against search and find out what the best scoring result is. Otherwise, we won't be able to actually access that underlying information. Another, which I'll actually demonstrate here in a little bit, is faceting and filtering. So we can actually inform the way we have the conversation based on what's in the data store. If we're at a music festival, for example, and we want to find out what kinds of music are playing, we can have a guided conversation where the bot shows the different genres, and you click into that. And if there's too much information to display, it might show the different days that they are playing. And that's faceting and then filtering over those facets. So let's actually just go ahead and jump into a demo that does exactly that. Great. So this is the Bumber bot. This is a Facebook Messenger bot I built almost a year ago now for a local music and events festival called Bumbershoot. And basically, it allows you to reason over the event schedule to figure out what you want to do based on where you are. Now, one of the first things you'll notice, when I say hi to this bot, it gets back with some buttons and says events, stages, days, and amenities. So it gets straight to the point to let me know as a user that this is how I can reason over this information. That doesn't mean I can't use natural language processing. I can say something like, where is the beer? And sure enough, it'll use NLP to determine that I'm looking for drinks and get me back an image with the list of all of the bars at the music festival. But we use these buttons in order to guide the conversation and give the user some context of what they can do. So the user can jump into events here. They might be interested specifically in music. And behind the scenes, I'm hitting an Azure search index and faceting over that index to find out what are all the different types of music I have available to, again, inform the way we have this conversation. So it gets back and says, I've got rock and pop or hip hop, soul, R&B. I go ahead and hit rock and pop. So it performs a search against the Azure Search Index, and because there are still so many rock and pop events at this music festival, it's not just going to send them all back to me. It says, why don't we filter this down even further by showing the user the days that rock and pop is available at this music festival. So I go ahead and hit Friday. And now that I've given the bot some threshold amount of information, it's going to get back to me with a carousel of all the different acts that are actually going on at this festival. And I can get more specific information here. Notice another thing we did here. We trained the user on how they can use natural language processing to get this same result. And it's very simple NLP. We say, hey, you could have also found this result just by typing Rock Friday. And this keeps the user from having to press buttons the entire time. Now they know that if they're looking for hip hop on Saturday, all they have to do is type in hip hop Saturday. Now, I'm also using fuzzy searching on this bot. So if I just say something like Tame Impala, which is an artist that was playing at this event, sure enough, I'll get a result that shows when Tame Impala is playing. But I could misspell that and say something like, Tame Impla. And behind the scenes, my bot finds that this still seems close enough to an event that's showing at the music festival that will go ahead and respond to it. I could say something like, who is Tame Impla? And I'm passing this whole message into my search index. So in this case, it actually didn't get the right answer because it's a little bit too much noise. Let's actually take a look behind the scenes at what an Azure Search Index looks like so that we can understand how we can build it into a conversational experience.
And we should highlight that it's very common to see developers trying to solve this problem with just natural language and nothing else. And the side effect is just natural language doesn't give you search, doesn't give you the fuzzy search, doesn't give you the indexing. So if you have a multi-million records database and you try to help the user to find the right thing, you will never be able to predict all the permutations of questions and model that in natural language. It's going to drive you crazy trying to do that. And that's when a search engine becomes the part of the solution, right? And that's why Azure Search in this case makes so much sense.
Yeah, exactly. We can use NLP combined with search to scrape out the entities that we think are relevant and then search those specific entities against our search index. So we can use them together. But very often, if you have some data store behind the scenes that's powering your bot, it makes more sense to just search and guide the experience over that data store. So this is an Azure Search Index. This is actually exactly the data that we used for this music festival. It's all JSON data that's sitting in DocumentDB. And you've noticed that we've taken all of these fields and made all of them retrievable, first of all. We want the bot to have access to all of this information. We've made the title searchable. So right there, when I typed in Tame Impala, this index is just searching over title. We could make it a composite index where it's searching over title and description. But in this case, we're just going to search over title. And then we've made the genres filterable and facetable so we can have that guided experience. So let's actually take a look at some queries against this exact index. So I'll go ahead and say search equals Tame Impala. And you see we get a result back with a score here. This is the API that we're using in order to build this knowledge base bot. And we can go ahead and say, hey, if we've hit some threshold score, let's go ahead and assume this is what the user is looking for. Now, that example that I didn't get a hit back, if I say instead, who is Tame Impala, you notice that score is fairly low. So if I remember correctly, the threshold score I set in my bot was 0.3. If it's higher than that, I assume it's correct. But based on what the score is, you can get results back to the user, or you can disambiguate. You might have 2 results in your database. You know, if somebody's looking for a John Smith, you might have several John Smiths. So you can disambiguate and show multiple results to the user and say, which one of these were you actually looking for?
And that's when we start wanting, we'll talk about this later, about the importance of collecting data and making our bot smarter. A lot of you guys reach out to us saying, how do I make my bot learn? Learn is a very generic term. Maybe part of learning is just figuring out when you're getting the wrong answer and fixing it. And how you do that is collecting that data, trying to find out what the user was searching for, why you couldn't find it. Maybe it's just a misspelling in your text.
Yep.
And so you collect that, analyze that, and improve it so next time your bot gets it right, right?
Yeah, exactly. So here I'm performing a facet query. Let me actually zoom in a little bit here. So I'm saying facet equals genres. And you'll notice that it's giving me back a count of all the unique genres along with the number of events that occur in that genre. So you can imagine that my code is just basically looping through this index and performing faceted queries and then filtering on that data and simultaneously supporting searches that are linked to it. So even though we are using natural language processing, we don't have to just use natural language processing, and we don't have to just use written words. We can use buttons to actually guide this conversation flow.
For a point?
Yep. So another tool that we've found is incredibly useful in building knowledge bots is Q&A Maker. So Q&A Maker is another cognitive service that we released this last year that basically scrapes existing FAQs, so basically just questions as keys and answers as values, and trains a model based on that language in order to to inform a conversational experience on some information. So without writing any code, you can just give Q&A Maker a link to your existing FAQ. It'll scrape it all, and you can start asking questions and start getting answers. Now, one thing I do want to emphasize here, this is a tool in a much larger toolbox of conversational experiences. If you just have a bot that does nothing but answer FAQs, then you'll probably disappoint your users because they're only expecting to type in questions, and you probably don't have all of the questions that they could possibly ask as part of your FAQ. So this is one powerful tool in our toolbox of knowledge bot development. Another very powerful tool, so in both of these examples, we have brought our own private data to some data store in order to inform our bot. With the search bot I showed, we put some data in a search index. With the Q&A Maker bot, we point the crawler to an existing FAQ. But there are obviously cases where we would want to inform our bot on some public data. Now, as one of 2 companies who's indexed the entire internet, we have access to information that can inform your bot and make it more, quote, intelligent. So using the Bing Knowledge Graph and the Bing Knowledge APIs, which are other cognitive services, we can inform bots on, for example, who Albert Einstein is. Instead of having to write all of our own data to inform a bot on public information or celebrities or places, we can just call the Bing Knowledge Graph and get some information back. So this is one example of an API call and the result that we get. And actually Zenbo, which Matt's going to demo at the end of this talk, is extensively using the Bing Knowledge Graph to inform its answers. You can find all the documentation on knowledge bots right here on this link.
All right, hand off to human. So this is a very, very common scenario, especially in larger companies, but I think every company has something like this where you have your users, your customers, they reach out to you either via voice or via chat with whatever problems they need to get solved. The first step is you go through some sort of triage where You ask some basic questions, usually the same basic questions over and over again. Who are you? What's your phone number? What's your problem? Blah, blah, blah. Are you already a customer or not? So all this basic data collection. And from that data collection, there are basically two scenarios. One is either it's a very common problem that everybody brings and it's very repetitive. We even have it scripted out for our help desk guys to go and follow it and answer. Or it's a very complex problem and it needs escalation. It needs some people to go look because it's a case-by-case thing. How do we use bots to help with this? So first step is in the triage space. So what you can do is you can have a bot that sits there and does this first answer, data collection, repeated questions step, either via voice, via phone call, or via chat. The reason for doing this is that now your customer doesn't have to sit and wait on the line until a help desk agent is available. He can start providing the right answers. When somebody's available, now you can just hand off those answers to that person, so you save both sides a lot of time by doing this. Right? So that's one good reason for doing this. Once you know what the problem is, let's assume it's a very repetitive problem. I mentioned the password reset, right? So imagine how many people call your help desk and say, I forgot my password. How do I do that? So you have a set of very well-defined steps. It looks like a recipe. So step one, validate the user identity somehow with either text message, social security number, whatever the steps to validate the user identity. Step two, reset the password. Step three, give the user something like a hyperlink, a new password, whatever, so they can recover their password. When things look like a recipe, guess what? You can program them. So what you do is it doesn't really require a lot of AI there. It's just really structural, procedural programming there to just do those step-by-step things. So now that my triage found out that the user has this problem, which is I forgot my password, you already have a whole automated process to deal with this and solve the user's problem. Now, there is the more complex case where you need an escalation. So now you need a person. There's no way around it. That's where you really need humans, because that's the stuff that there is no automation to deal with this. How do we hand off from that automated conversation with a bot to a person? There are two ways, basically, summarize, there are two ways we can do this. One that's very simple, which is the complete handoff. So the bot says, okay, I'm done. I can't help you anymore, so I'm bringing John here to this chat. John, user John, you guys sort it out because I don't know what to do anymore, right? So the bot steps out of the conversation, and we have a framework for it. It's open source. It's very easy to use. It works on any channel. You can do that on Facebook, on Slack, Skype, anything you want. But there is the other case where I think it's particularly interesting, which is the supervised handoff. In this case, the user remains in the conversation with the bot. The bot doesn't step out of it. But now the agent, the help desk person, is watching the conversation. And whenever an important decision needs to be made, the bot goes to the agent and says, okay, what do I do now? And I offer some buttons there, like, for example, apologize to the user, suggest a hardware replacement, or let me type. That's a case where I have to type. Now the help desk person goes and says, okay, suggest hardware replacement. There is already a script for that. I don't need to go type, okay, I suggest you to bring your laptop, because then, no, we already know how to, the bot can take care of it. All that the help desk person is doing is making that important decision. So what's interesting about it is, again, the best bots, they make you type less, not more. They save you time. So what you're doing here is saving time, but the person is still in control. Not just that, but as that user is clicking on those buttons and making those decisions, we're collecting this data. And this data is going to be used to make the bot smarter. The bot over time will get smarter at making those suggestions of what's the next action to take. So this is very, very helpful, because whenever you talk to any company that has a help desk, they say, yes, please, this solves a lot of my problems. This simplifies how I handle those. This creates a standard way for me to deal with certain escalations from users. So we quite like this model. And again, this is a design partner as well, documented. We have a framework for it. You guys can totally take a look and reuse it. The next thing is back channel.
Yep. So when we as humans have conversations, we actually use a lot more than just the words we're saying to communicate. Gestures and facial expressions, different sounds, physical movements can convey some more information behind the scenes. So when we're having a conversation with a bot, we might want the bot to be more context aware than it is. More than just the words we're sending into the bot might inform how it should respond. You can envision a bot sitting on a web page that might be, selling something. You want the bot to know exactly what you're looking at when you're on this web page so you can inform the answers it will give. Otherwise, it's kind of a disappointing experience if the bot doesn't know what you're actively doing on this page. So we use this thing called backchannel, which is the practice of maintaining a real-time side conversation alongside a primary conversation. The key thing to note here is that the information that's being passed back and forth through this backchannel is not at all visible in this chat that you're used to. There's stuff being sent behind the scenes. It's all invisible to the user. So the first pattern we see with backchannel is backchannel and websites and applications. So you might need to communicate the clickstream or user behaviors of a user on a website or a web app or an application to the bot to inform some context. You can also have the bot communicate changes made in the conversation to that actual hosting page or hosting application so that you can do things from the bot that actually affect the canvas that it's sitting on. One of the biggest use cases we see for backchannel and web apps and applications is to pass authentication tokens back and forth. If you're on a website and you authenticate on it, you don't want to then jump into this bot experience that's embedded on the page and have to re-authenticate there. You kind of just expect that if you're authenticated on the page, your bot is able to make authenticator requests on your behalf. So by passing authentication tokens through this backchannel, you can then allow your web service to access the information that you need on this web app or application. So I'm going to go ahead and show another demo here. This is using our web chat. It's a very basic UI. I'm not going for anything big and beautiful here. And I'm basically going to chat with it in a way that it can communicate with the hosting page. So I'll go ahead and just say hi. And it just echoes. I might tell it background black. So what I'm doing here is having the bot send a message to the hosting page to actually change the background. It's fairly simple, but it can actually be very powerful for specific scenarios. So I might say, show me a graph. So I can have a conversation with the bot to actually reason over some data and visualize data, get some information back. And again, this page is context aware of what's happening in this conversation. The hosting page and the bot itself are essentially talking to each other behind the scenes of this conversation. Now to demonstrate that other direction, I'm taking a look at this graph and I click on something. And that might inform what I want to see in the conversation. So you see when I click on different things, I'm now sending messages from that hosting page to the bot itself, so the bot is aware of what I'm doing on the page. Now this is a little bit of a boring graph. Go ahead and say this is boring. Get a bit more of an interesting visualization here. And I can alter what's going on in the visualization by saying something like fewer polygons to make this kaleidoscope a lot more simple. It's a bit of a silly example, but you can imagine there are tons of different ways that a bot and a page might need to interact.
Yeah, what I like about it is Ryan's not trying to replace the chart. The chart is good for what it is meant for. It's visual. It has a lot of stuff there. Like if the bot tried to describe everything that you're seeing here, it would be so hard. But the bot becomes a complementary experience to that chart, right? I can go back and forth. So imagine, like many of you guys bring scenarios like the customer is working on some form on a website, and now they need help with the chatbot. And it would be silly for the chatbot to ask obvious questions that are on that page, like, what's your name? I just typed my name here on this form. Why do I have to tell you again this information? So now the bot can go and save a lot of typing by grabbing this data from the form, right? So that's where the back channel, it's basically your JavaScript on your page having a whisper conversation with your bot without the user seeing it. Okay? Oh.
So that was an example of bots using backchannel and web applications and in applications. We can also use a notion of backchannel with devices and with things like robots, as Matt's going to demonstrate at the end of this talk. So we can use the back channel to communicate some visual or oral context. Like I said, when we're having conversation as humans, not only are we communicating with what we're saying, but also what we're doing. So having a robot send images to our bot endpoint to inform it on what's going on in its environment is certainly valuable to the ultimate conversation and might inform that ultimate conversation flow. We might also send sound and tone of voice and any other information there. We also might communicate sensor data. So you can imagine, say, a smartwatch. You're running along and you can chat with your smartwatch and you might be curious as to what your heart rate is at some point. You can communicate that sensor data, again, through a back channel to the bot behind the scenes to inform that conversation. So now this conversation could get back to you and say, oh, your heart rate is this. You've been running at a pretty high heart rate for some time. Good work. So you can communicate all of this different sensor data through the back channel as well.
All right, so another very common pattern we frequently use is bot web. Bot web basically means at some point I can't do whatever I need to do within that bot window, that chat window alone. I need to send a user to a web browser to do something and then go back to the chat. Typical scenarios, authentication. Right? I'm using text message or using Skype or Facebook, whatever. I need to authenticate the user to go to Office 365 or to go to Google or to go to my CRM system or Salesforce, whatever that's behind, and I need to go grab a token. That's a common scenario. Another scenario is, for example, certain kinds of payment systems. PayPal. We had cases where somebody built a chat that needs to invoke a PayPal page. So I launch the user into a browser, they do the PayPal payment, and come back to the chat. So there are a few reasons why you would do that. And the way we do it is, as step one, in the conversation, the chat, we give the user a hyperlink, say click here. The user clicks on that hyperlink, launches a browser, right? And the bot enters in a waiting state. The bot says, okay, I will sit here and do nothing until that web page tells me they are done. They finished whatever was supposed to happen there. The user then does whatever authentication, payment, et cetera, et cetera, et cetera. We usually add this additional step, which is the page generates a random magic number that the user needs to copy and paste it back to the chat. Why do we do this? Because we like to make users' life difficult? No. It's because it's an additional security step. You have to think that, for example, in that chat window, there could be 10 users together. So the bot just gave a hyperlink there. I can't tell which user clicked on that hyperlink. So the reason why we generate the magic number and ask the user to paste it back to the chat is so we can validate, oh yeah, that was really you, the guy who just did the authentication here, this token I just got, that's really for this user in this chat. So we can make sure nobody else took your hyperlink and did something with it. Once that's done and the user pastes the number back, the web chat and the bot, they talk to each other. So they exchange information. The website says, this is the whatever, the access token, the payment confirmation, whatever you asked me for, that this user just did, right? So what we can do here is continue the experience outside the chat window. And what's interesting, this works on virtually any channel. So you could be on Facebook, authenticating on Office 365, and asking Facebook to list your OneDrive files. You can do that. You can be reading your calendar. It could be like anything that's behind an authentication token, you could be doing it here, which makes it very interesting. So there's lots of you guys are doing bots that check your calendar, automatically book meetings, and search for your files. That's how you do it today. That's exactly how we do that. We have a hyperlink here, so later on you guys will be able to download this PowerPoint. This is another link where we show how to do this in details. We have authentication libraries, open source in C# and Node that helps you with that, with exactly this scenario. Another scenario, that's a hard one to call a pattern. It's just that it's so common that we're calling a pattern because we see that a lot. Surprisingly, not all bots require having conversations. That's kind of an odd thing, right? Well, you're building a bot, of course you're having a conversation. Not really. In some cases, you don't need it. In some cases, all you're building is just a bunch of buttons and rich UIs. You could totally build that as an app. That's fine. And in some cases, the reason why people build that as bots is just because it's easier. It's easier to build. It's easier to deploy. You don't have to test it on a lot of different UIs and platforms and Android and iOS and different screen sizes. You just build it for Skype or Slack, whatever you prefer, and it's done. So because of the low cost and the simplicity, in many cases we see app developers building apps. They look like apps, but they're built as bots. So that's fine, and that's kind of funny when you see people overcomplicating simple scenarios that you could solve with 2 buttons and putting a lot of typing, a lot of natural language. Like, why are you doing that? It's just 2 buttons, yes and no, and done. Like, yeah, but that's not AI enough. Does it matter? Like, does it solve your user problem? That's great, done. So it's just to remind you guys that not everything has to be about having full-on conversations in a bot. In some cases, it's totally fine to have simple solutions. So what we did here in this doc is we tell the story about a typical app developer. They need to build, again, the example of the password reset bot. And the suggestion is, forget you're building a bot. How would you document that? You document the UIs, the specs, like how the functionality would go, the little buttons, right? When you finish documenting that, building that as a bot, it's almost the same as building as an app. And then we show how that would look like as a bot, right? How this code would be deployed if we build that as a bot. And that's totally fine as a decision. To demo a little bit of those 2 flows I just mentioned, we have this thing called Azure Bot. So today you saw the new Azure mobile app, which is great. Until a few days ago, if I had to stop a VM on Azure using my phone, what were my options? One is launch the browser, log on to Azure, right? Find the VM, right? Good, scroll, find the VM, stop it. Hard. The other option would be open Skype, right? Either on desktop or on my phone, and say list VMs. I think it's list VM. And maybe I need to refresh because this was sitting here for, oh, there you go. And then I can say stop VM mat VM test. And I'm done, right? And what we did here is a very, very simple bot that's actually open sourced that uses the bot web flow so I can authenticate the user. It's already stopped, great. So, and then applies that on Skype. So this is Skype consumer. Skype consumer doesn't know what's my AAD identity, doesn't know how to go to my Azure subscription, but it's bound to my AAD identity, and it can do that for me. What's interesting about it, if I close this computer now, if I grab my phone and open Skype, it's exactly at that point. If it was asking me yes or no, do you want to stop this VM, I could just say yes on my phone and continue. So the data synchronization, you get that for free. Imagine building that in an app. It's a lot of work to do that in an app, right? And here, you just got that for free, just because it's a chat window and that conversation history carries over across platforms. And likewise, I could just log out here and say, forget who I am, forget my AAD credentials, and I can say log in again. And what I'm doing here is exactly the bot to web flow. So if I click on this button, what happens is I'm launching a OAuth flow. I won't do the whole thing here, but I'll authenticate again, right? Generate a magic number. Close this, go back to Skype, and now I'm authenticated. What's cool about this, it works on a web browser. It would work on my Skype on my mobile. It would work on Skype on desktop, on Slack, on text messages, on Facebook. Doesn't matter. So that's a very flexible cross-platform way of doing things. So that's why many companies, we see that a lot of people saying, we have all these little apps we would like to build. We're never going to invest money to build these as apps. But maybe as bots, yeah, we will, because it's simple enough. It's easy to build. It's easy to deploy. So we will totally do it. So that's an option as well. With that, that's on you.
Great. So another pattern we see, and we're just going back to back here, but as Matt has emphasized a couple of times now, all of this is documented in detail on our open source documentation page. Another big pattern we see is proactive messaging. So typically when you think about a conversation with a bot, you say something, and the bot says something back. But you can certainly envision some use cases where you want your bot to reach out first. So you might have a reminder bot that reminds you, or that lets you know if the weather is bad, and every morning it it proactively reaches out and says, put on a rain jacket because you live in Seattle. And that bot would actually be very easy to write because it wouldn't have to make any API calls at all. So in order to perform these proactive messages, the most important point here is that you need to retain the user's address in some table and then run some routine on some schedule or on some trigger so that you're retaining that address so you can then proactively send a message out to that address. So here you see some very basic Node code that's saying, the first time that someone sends me a user, let me go ahead and remember their contact information so that I can put it in this database, and then based on what preferences they set for a notification, I can run some job that goes ahead and sends out messages from the bot to this user. Now, you definitely need to consider some user experience concerns when building bots that do proactive messaging. For one, you don't want to just constantly spam users. You can imagine you can use proactive messaging for a bot if it hasn't heard from a user in a long time or wants to check up on something the user mentioned a long time ago. But you don't want to send tons of back-to-back-to-back proactive messages. That's kind of annoying. Here's another example where you have a travel bot. And it says, what city are you traveling to? Since you're looking for a reservation, you say London. It says, what is your planned date for the trip? And then it sends a proactive message from a conversation you had a long time ago saying, good news, your preferred hotel in Las Vegas is offering a discount. Want to book a trip? So for a user, this would obviously be a pretty jarring experience. So when building out proactive messages, you want to think about things like whether or not you're in an active conversation right now. And if so, you might choose not to use proactive messages. You might choose to send one once this part of the conversation is done. And this, too, of course, you can find more documentation on. Another pattern we definitely see very frequently, Matt alluded to it earlier, are global handlers. So when we talk about these dialogues, we think about you being locked into some part of a back-and-forth conversation. And if your bot asks a question like, are you still embezzling money from your company, yes or no, you might want to be able to jump out of this part of the conversation flow because either of those answers are pretty bad. So we have this notion of global handlers where you establish this handler that's looking for some specific thing, some command, some natural language being triggered. It could be a regular expression that will always jump back to some other state or some other dialogue. So most bots that we build, for example, reserve the word help to jump out of the current dialogue that a user is in, jump out of that context, and jump into some help flow, so a user is never locked into some point in a conversation. And then the last pattern we're going to talk about, not even a pattern, more of a thing that you should really do when you're building bots, is to collect telemetry, to collect data so that you can improve this experience over time. It's important to see what your users are doing, what intents they're hitting, whether or not an entire flow is even being used at all to actually inform how you can better this conversation. We've got tons of tools out there that make collecting telemetry very easy. App Insights is hooked up to Azure Web Apps. So if you deploy a bot to Azure Web Apps, you can seamlessly gather information about what channels people are hitting your bots from, about what intents they're hitting, gather all of this information that might inform how you better that bot in the future. You can only manage what you can measure. We also have Azure Machine Learning, so you could actually improve some model over time based on the conversations you're seeing and on whether or not people report that they are happy with the conversation or unhappy with the conversation. That might influence the way you actually train your natural language model behind the scenes. And then, of course, we've got Power BI to visualize to visualize all of these metrics, so you can have a visual sense of how your bot's doing and what it's doing.
All right. So to finish this, I want to show a very cool demo. So I want to introduce you guys to my little friend here. His name is Zembo. Sorry for the guys over there, like you might not be able to see him very well. So he's Zembo. And Zembo is a super cool robot built by ASUS. And there's lots of things I love about Zembo. One is the super cute face. That's actually a touch screen, which makes Zembo very useful because you're not limited, constrained with just voice. You can have a UI there and do a lot more with that UI. And ASUS was super kind to let us borrow some Zembos for the past few weeks. And for the past few days, we've been literally hacking a bunch of ideas that we had about how can we plug the Microsoft Cloud into Zambo and to try to apply a lot of the ideas we've been talking about here today, knowledge-based scenarios, contextual conversations, using more elements than just speech. And like, for example, can we make Zambo react differently based on what he sees, for example? Maybe if Zambo is talking to a child, the answer should be different than when talking to an adult. That's a thing you should consider, right? So what I'll try to do here is show this prototype. There's a good chance it may not work. Quite honestly, I never tested with this sort of acoustics and this sort of light, and like, it may not work at all. If it doesn't, I have a video that I recorded yesterday showing everything working. But I want to try it live just to see how far it goes. So the only thing is I'll ask you guys to try to keep quiet as I go with this, because otherwise we might confuse him quite a lot. And at 3:30, over the Code Theater, which is, I think is over there, I will do a 20-minute session to go deeper into how we built this. I will open source the whole bot behind of what I'll show right now, assuming it works. So let's try that. Hey, Zambo. Who is Scott Guthrie?
According to Wikipedia.org, Scott Guthrie is an executive vice president of the Cloud and Enterprise Group in Microsoft.
How old is he?
Scott Guthrie is 42 years old.
Who is Melinda Gates?
According to Wikipedia.org, Melinda Gates is an American philanthropist, former Microsoft employee, and wife of Microsoft founder Bill Gates.
Who is her husband?
Melinda Gates' husband is Bill Gates.
Where is he from?
Bill Gates was born in Seattle City.
How do I do a bubble sort?
Bubble sort, sometimes referred to as sinking sort, is a simple sorting algorithm that repeatedly steps through the list to be sorted, compares each pair of adjacent items and swaps them if they are in the wrong order. The pass through the list is repeated until no swaps are needed, which indicates that the list is sorted.
Look.
All I see is an empty room. Where is everyone?
Look.
I think I'm seeing a drawing. What is it?
It's a picture of Isaac Newton.
According to Wikipedia.org, Isaac Newton was an English mathematician, astronomer, and physicist who is widely recognized as one of the most influential scientists of all time and a key figure in the scientific revolution.
When was he born?
Isaac Newton was born on December 25th, 1642.
Go. So, it works.
Yeah.
Go. Let me...
One thing to emphasize there is that none of that was hard-coded at all. Matt built this thing in like 2 weeks just using Bing Knowledge Graph, not following any contrived conversation flows, but actually making calls over to the web to actually ask these questions and pull information back.
Right. For folks who are watching online, I'll put a video showing Zambo. So the thing is, every time I ask a question, we're using Zambo's face to give it more details. That's actually, we're sending HTML with the bot framework, so you can have hyperlinks, you can have a bunch of stuff. It's the beauty of, like, if you think about how we communicate in the real world, right? It's not just voice. There's like gestures and facial expressions, and I may act differently if I'm talking to a child versus an adult, right? Different questions. So all these things together, all this context, makes a real natural interface. And that's what we're exploring here with Zambo, which like I'm really having the best time programming with him. There are lots of folks here from ASUS. I want to thank them a lot for letting us play and having all this fun time with it. And if you want to know more, 3:30 over Code Theater, I will be explaining more about it. Right?
Yep. So we've got 5 minutes left that we can open up for some questions and answers. Hopefully some answers.
Yes.
In the off scenario, when you have a redirection to the site, like you kind of talk about it in the two contexts, the one with the back channel communication and then the bot to web.
Yep.
So in that scenario, could you not use a back channel to communicate to the bot? Say you're talking with, you've got a messenger, a Facebook Messenger bot, you need to go to your website to authenticate. Can you use the back channel to send the token?
No, unfortunately, Facebook is not a web control I can host on the website. So the back channel requires the control to be hosted on the application itself. In that case, I have to do the bot to web and back. But some channels, they are very good at, they have their own web visualizers, exactly so you don't have to throw the user all the way to a web browser and back, right? So they have their own little web controls.
Sorry, go ahead.
So in that scenario, then it would be go generate a token and say paste this back into our bot and then we can continue?
Well, I'm never going to give the user the token. All I give them is a validation number to prove that the token is sent behind the scenes. But we don't use back channel there. There's another way where I can call the bot framework and say, here's my state.
But at least in that scenario, I'd be able to figure out in my Facebook, in that channel for that bot, I know who the user is, and I can just start calling my API and figure out more information
Yep.
about that user.
Sure.
Yep. Let's go ahead and take the question from this mic.
Yes.
Hi. Hello. So my question is around identity. So when you're, say, initiating a conversation from Skype or Slack with a bot, is it possible for me to know the identity of who's talking with me so I can authorize them to do certain things and not others?
So in order for a bot to reach out to a person, it needs to have spoken to that person before. So a person needs to initiate some conversation with the bot. Now, depending on what channel you're using, they might surface some other information behind the scenes. So Facebook Messenger, for example, might surface some information about the profile that underlies the user that's chatting with the bot, such that the bot could have some context for that conversation. But that's all channel specific.
So things like Slack or Skype, will typically have some profile information that you can use. It's going to be different for each one, but
It's different for every channel.
Slack has its own APIs for this, where you can go and query information about the user. On our platform, we have basically two identity models. One is Azure Active Directory for corporate users. Another one is the Microsoft MSA, which is our Hotmail, Outlook.com identities, which are consumer focused, right? So either way, we have some APIs where you can go and query more information. So for example, if you're using a corporate identity, my Microsoft.com corporate user, once I'm authenticated, I can go and grab information about Ryan is my peer, we report to the same manager, and here's my files in OneDrive, and here's my job title, so I can get all this organizational chart out of that Microsoft graph.
okay, thank you very much.
Sure.
Yeah. Do we have a channel for Skype for Business now? Yes.
Now
So
we do, yes.
As of today, we have a channel for Skype for Business.
Yeah.
Can we get the login user ID in that channel if I basically connect to that?
Sorry, can we log in with?
So if I use the Skype for Business,
Yes.
can I see the identity of the user?
I don't think we have both for Microsoft I could be wrong, but for Skype for Business and Microsoft Teams, we don't automatically plug your authentication token from the client so you can use from the bot yet. It's a thing we've been discussing with the product team, like can we save the user that step of authenticating again with the bot? Today, we intentionally obfuscate that information and we force the bot to do the authentication, because otherwise what could happen is several different bots could start tracking you without you knowing about it. So today, we don't have a good story for it, but we are working on a very good consent-based story that's integrated with these channels.
It makes sense in case of Skype, but if it is for Skype for Business, then it means that the user will be from the enterprise.
Yeah, I agree, and they agree. It's just not there yet, but we will bring that to this platform.
And for now, you could still bake your own custom authentication flow.
Yeah,
Right,
But that ideally, if you're already logged in, you want to be able to access
it
that.
totally makes sense. Yes.
So it seems like there's some like session data or the persistent data stored somewhere in some in the cloud.
Yep.
So if I want to store the data in my on-premise, is it possible?
Yep.
Or what kind of database I need?
Right,
Is
so
it schema
yeah,
I need to
the
follow?
bot framework has a little state API, but usually what we tell people is override that and write your own, because you want to save your own data anywhere you want. So all you do is you take the user ID from the conversation ID, and probably the channel ID, so you have those 3 identifiers.
Okay.
And then if you want to try to use your own SQL Server on premises to save that data, that's totally up to you. You can totally do that.
We've actually seen a customer extend the bot state with Redis in under an hour.
Yeah.
Oh, okay, that's good. Because sometimes I need to store my
Yeah.
own data.
You need to be careful with latency, right? If you keep going back and forth too much, right? But yeah, you can do it.
Another question I have is there any way I can make a load test on the bot? Because my understanding, I can only create an emulator, only
Yeah.
can represent one user. If I want to,
You can load test, so that's a very good question. Yeah, load test is a tricky thing. So remember, your bot is a web service.
Yes.
You can load test it just like you would load test a web service. What you don't want to do is do that behind the bot framework. So some people, they do that. Like they use the bot framework's direct line. They plug the bot into the bot framework, and they try to load test the bot framework itself. The bot framework will think you're doing a denied of service attack, and it's going to kill your connection, right? It's going to defend itself. So if you want to load test your web service, you will do it from outside the bot framework. You're going to call your web service directly, because now you're testing your thing, not the Microsoft plumbing behind of it, right?
The same applies to individual channels. If you're sending tons of data in through Facebook Messenger at a specific bot, Facebook Messenger itself is going to think you're trying to perform a DDoS attack.
Right.
can I use like a video, online video studio to spawn multiple?
You can use Visual Studio, but it's not going to be so straightforward, because you have to send the payloads in the way
Yeah.
the REST
Yeah,
API expects, right?
That's my question, right? How
Right.
can I emulate?
Yeah, so, but what you can definitely do is you can put some network log like Fiddler. You can look at what's coming, right? And adopt from that and build a script that you can simulate over and over again. And then, yes, you could use Visual Studio for that.
All right, thank you.
Okay, sure.
Yep, we mentioned custom channels. I'm echoing you for the sake of the people on the
So yes,
watching
so
live.
I was running a demo
Yep.
for next month for my user group to use function serverless as a backup for bots or Alexa in this case, just because the skill set is not.
Sure.
Can you use a custom channel to hook up your bot to Alexa?
Yeah, absolutely. So you can use our direct line API, which just basically turns the entire bot service into just an API call that you make. And then you have a web service that's receiving the results and sending it into an Alexa skill or a Cortana skill or your own custom speech service or your own custom site.
That documentation is cited. So
Yep.
that's something.
Yep. Look up direct line.
Thank you.
Yep.
I'm still confused about how to protect the spy data. So your recommendation is to go to the back channel, collect the user sensitive information, and talk back to the chat.
Yes.
How, what is a good practice to handle this kind of? For example, SSL, right? You don't want to use a Facebook Messenger to type their SSL there.
Absolutely.
Maybe the Facebook can log all the
Yes.
stuff there.
Yes.
So what is
Yes. So the question is, if I'm using Facebook, for example, Facebook logs the entire conversation between the user and the bot, whether you like it or not, right? And so you don't want the user typing stuff like credit card numbers, right? Stuff like that. And that's usually when we take the user out of that channel into a web page and back, right? And that's where we use the bot to web pattern. So we generate a hyperlink, send the user to a web page. There may or may not be authentication involved. That you may want to, maybe it's a flow where you want to revalidate the user. How you're doing this, like any other website, just go out, whatever flow you do to authenticate users. So if your site already has an authentication, you still do it, right? Once the website is done, the website talks to the bot framework and say, tell this bot that this thing is done, and here's the result, right? It's like I'm invoking a remote procedure call. Like, here's my result.
So it's going to be the same way the website talk back to the bot, like the authentication process.
Yes.
The callback link.
Yeah,
Yes.
exactly.
Or something.
Exactly, and I see your point of confusion. When I was talking about the back channel, you can only use a back channel when you control the canvas that you're using. So when you own an application that a bot is hosted on, or when you own a website or a web app that you have the bot on, and now what you're enabling is the bot to speak to the parent page. So if the parent page authenticates and has an auth token, it can pass it to the bot. If you have a bot that's published on something like Facebook Messenger, then you've kind of got a different story because you don't own the Facebook Messenger canvas. So that's when you use the auth flow that Matt's talking about, where you jump out to a website, auth there, it lets the bot know that it has your information, passes over the auth tokens, and now your bot web service has the auth tokens.
So when you're saying, in that context, sorry for the...
No worries. I realize it's really confusing. It's a totally
There's
different.
a lot of new concepts too. So
Yeah.
in that scenario, when you say that you realize that you've got the tokens,
Yep.
is that saying like I'm starting in like the property bag for that user, or like where am I managing that? Like how do I?
Yeah, so basically there is a state store, the bot framework, where it's per user, per conversation, per channel, right? So I can go there and say, for you, in this particular conversation, remember this.
And that's the private, because there's a public bag, there's a user bag, and then there's a user conversation.
Right.
Data set as
But
well.
let's imagine none of that exists. Like, let's forget about it. If you have the user ID, if you have the channel ID, you can go to any store, Blob Storage, SQL, whatever, and say, for this user, for this ID, I'm saving this variable, right? So now all they need to exchange with each other is which one is the user, which one is the channel, right? And then you can go to the same store and get this data, right?
We've got to get off the stage, unfortunately,
Yeah,
but
sorry.
happy to have some conversations outside.